Okay. 8.3, the more I'm looking into this logarithm unit, the more excited I am that it's the last unit we're doing, because if you put the time in, this is a unit that seems like a nice break from Trig 1 and Trig 2. So it's a bunch of simple rules, and I know it's kind of a new language for us, but again, you wrap your head around it, and it comes together really nicely. So a couple things to remember. 8.3 is evaluating logarithms, and this is basically the entire note. I think the video is going to be under 10 minutes for sure. So the first thing we have to remember is sometimes we have things in exponent form. So these are equations. 5 squared is equivalent to 25. That we all know. 4 to the power of negative 3 is 1 over 64. That we all know. This is the only form you've seen this sort of relationship exist in, and that's called exponential form. Well, we've now been introduced to logarithmic form, which gives us the exact same sentiment. Remember, in logarithms, you look at the base and you say the base to what power? So that's the answer over here in this equation. So 5 to the power of 2 gives us 25. Okay, remember, it's sort of like when you're thinking about it, this is the answer, this is the exponent, this is the base. Okay, so in this one, this is the answer, the 1 over 64 goes in there. This is the base, and this is the exponent on that side. So the way of thinking you should have here is 4 to the power of negative 3 is 1 over 64. And so because these are always set up as equations, you could write them either way. They're both correct. Okay, they're both correct statements, whether it's in logarithmic form or whether it's in exponential form. And obviously you're more used to exponential form, but it doesn't make this less right.
There's a baby bunny.
There's a baby bunny? Oh,
yeah.
Good. Okay.
I can't get through.
Hi. You want to come say hi? You look a little bit. Oh, Jamie's still. You want to come say hi? What do you say? You're cold? Well, go inside then. I'm almost done. Okay. Are you going to stay here or what? Okay, so when you want to evaluate them.
Video?
This is my second one, yeah. So when you want to evaluate
Is
them.
that all you have, too?
I have 2 more. I don't know if I'm doing them today or tomorrow.
No.
Okay, if you are evaluating them, then obviously you're missing this part of the equation, the other side. So in a logarithm, you really have to think, like, in your head here. The thought should be 3 as a base to what exponent gives you 27. And that's what the answer is going to be. 3 to what exponent gives you an answer of 27. So we know it's 3 to the power of 3. You think the same thing here. It's in your head. 5 to what exponent gives me 1 over 125? Well, you'll recognize the fact that this is a number less than 1. That has to be a negative exponent, right? So we know 5 cubed is 125. So 5 to the negative 3 would give us 1 over 125. Okay, so every time you're sort of thinking that, again, obviously you don't draw the thought bubble. This is just me trying to show you. 2 to what exponent gives us negative 4? Okay, no answer here, no solution. I guess we should write not none. Be a little more official now. Okay, so here you should write no solution. Why is there no solution? Because 2 to any exponent is not going to give you an answer of negative 4. Okay, it's impossible to get an answer of negative 4 doing 2 to some exponent. So no solution exists to this relationship. Okay, now here, some thinking should be done in what exactly this means. So 25, the third root of 25. Okay, what does that mean in terms of what you're going? So this is really equivalent to, I'm going to run out of room here, log base 5, and this is 25 to the 1/3. So that's still not, you can't do 5 to what power gives me 25 to the 1/3. But if you can make this base here the same as this base here, it becomes a really easy question. So the trick with these ones is, can I rewrite 25 as 5 to the something? Well, you know that 25 is the same thing as 5 squared. So if I have 5 squared and I multiply that by 1/3, I get 5 to the 2/3. So now when you ask yourself that thought bubble, I'll do it up here, you're saying 5 to what power, right? In the same way we did here, 3 to what power gives me 27? Well, 5 to what power gives me 5 to the 2/3? Well, now that's sort of a same base, equal power. They both have the same base, so obviously, if this exponent is 2/3, what is this exponent? 2/3. So that is equivalent to 2/3. Okay, so sometimes when you get into a messy one like this, you try to make the base of this value in here the same as the base of your log function to make it a little bit easier. Okay, the next skill we need to understand is sometimes the base is not written. And if the base is not written, we assume that it's base 10. Okay, so a lot of times you'll just see things written in there. Find the log of 100. Find the log of 1,000. Whatever it happens to be. It can be anything. If there's no base written, so there's no a value here, we assume it's a 10 always. Okay, so log base 10. And in fact, on your calculators, there is a log button. On this one, the log button is the second function of the number 1. Depending on the calculator you have, you should look for it. But it can only evaluate logarithms that are base 10. Okay, so this is what we call the common logarithm when it's base 10. So in all of these, there's 2 things you could think of. You can do it on your calculator, of course, because that's now to your advantage. If you don't see a base, you can use your calculator. But if you just think for a moment that this is actually base 10, you're really asking yourself, 10 to what power gives me 100? Okay, 10 to what power gives me 100? Obviously 10 squared is 100. Okay, but again, I can just go on my calculator, second function log of 100. What does it pop out? 2. Okay, again here I'm thinking 10 to what power gives me 1 over 1,000? Clearly a negative. But again, I can go second function log, put it in brackets, 1 divided by 1,000, -3. Okay, so it gives you the answer. Now this one, you definitely have to use your calculator because it's going to be a decimal answer. We don't know 10 to what power gives you 57. Okay, we have no idea. We know 10 squared is 100, so it's going to be less than 2. 10 to the power of 1 gives us 10, so it's got to be greater than 1. We know it's going to be a number between 1 and 2. We don't know what it is. So we just do second function log of 57. And I get 1.76. Okay, we knew it was going to be between 1 and 2, so that confirms that for us. Okay, so your calculator is your friend only for base 10. If you are being asked to evaluate these, you will not get the right answer if you try to put any of these in your calculator. It has to be base 10. That's the only time the calculator will work. Okay, so be very careful with that. Otherwise, you're going to have to use the old-fashioned methods of thinking from logarithms back to exponents to try to evaluate some of these. Okay, so the next little section here is some properties of logarithms. It's basically the idea, remember we had all those exponent laws in grade 11? We started them in grade 9, and then in grade 11 we listed, 8 or 9 renditions of exponent laws. Well, because logarithms are the inverse of exponents, there's a bunch of logarithm laws as well. So we're going to get started on the first few laws that we want to know. Okay, so a couple things they note. This is only good if a is greater than 0. We're not going to have negative bases. And we want to make sure it's also not base 1. Okay, so those are the restrictions. So the first law goes like this. Any base you have, if you're doing log of 1, is going to have an answer of 0. And think about why. Because we know a, doesn't matter what a is, to the exponent 0 is going to be equal to 1. That's why that law works. So that's just the inverse law of our 0 exponent law. Okay? So anytime you're doing logarithm of 1, doesn't matter what the base is, the answer is going to be 0. The next one is what we just saw sort of on the previous example. And it looks a little bit confusing, but if you're doing logarithm of a to the x with a base a, then clearly the answer is just x. And that's what we just saw in that previous example with 5 to the 2/3. So it's really saying, remember, a to the exponent x is going to equal what's here, a to the x. So that's sort of why that makes sense. So sometimes when the reason we're learning these laws is we're going to start solving more complicated problems. But if you can get the base of the value in here to be the same as your logarithmic base, then the solution just happens to be whatever that exponent is on that base. Okay, so that makes your life a little bit easier as well. Okay, and the last one, which looks very ugly, this is a with an exponent of a logarithmic function, and this is going to be equal to x as well. There's a proof there for you if you want to see it proved, but basically you just need to be able to recognize these scenarios and know how to evaluate them in terms of, is their answer x, is their answer 0. So there was one example listed here, and only one. If I had 4 to the log 7, what would that be equivalent to? And again, you're looking for, in a way, if this base here of the exponent matches the base of the logarithm, that's the key, then the answer is simply going to be that exponent. Okay, so you'll recognize those because very, very infrequently are you seeing logarithms in the exponent. So as soon as you see a logarithm in the exponent, you know that's going to pop out. Okay, I highly suggest you get started on this homework. It's not overly difficult, but there is quite a few questions, I guess. Now, the note seems not long enough to me, like there must be another part of it, but that's all I see. Okay, so 8.3, done. What we have left, and we've really shrunk the logarithm unit quite a bit, basically due to time restrictions. So what we do have left is we're going to go through all the laws of logarithms. So if some of the questions don't appear to make a ton of sense in 8.3, they're gearing you up for the laws of logarithms, so don't get overly concerned about it yet. So once we learn all the laws of logarithms, we can solve a bunch of problems, which will make our life a little bit easier. That's going to be 8.4. It'll be more of a lengthy lesson, and then solving exponential equations using logs, which is the whole point of this, and that's what we're getting to. 8.5 is going to be the big lesson. Too bad we don't have enough time for 8.6 because it's interesting also. Okay, so the next two lessons are going to be a little more in-depth. I would say 8.1 through 8.3 is a warm-up for what we really want to learn, which is from 8.4 and 8.5. Okay. A couple questions should be answered for you today. One, I definitely don't have blonde hair anymore. Just a ponytail. I'm very gray. And I have these Mission Trip t-shirts in long sleeve and short sleeve now, you can see. Okay, I call it my uniform. All right, I'll get started on 8.4.